Hi everybody. We are group 5 and we will be presenting on the addition and subtraction of integers using different methods. To begin, I found this quote by Horace Mann that I want to share, and it says, "Every addition to true knowledge is an addition to human power." I found this quote to be very inspiring and interesting because I truly believe that knowledge is power. My name is Taylor Richardson, and today I will be discussing different strategies that can be used in solving addition problems. These strategies are by using colored counters and by using mealtime stories. To begin, we'll talk about the addition of integers. An integer is just a whole number that doesn't include a fraction or a decimal. And the addition of integers is the combination of any two whole numbers. Next, we'll talk about the addition of integers by using colored counters. Colored counters are helpful for visual learners because it gives them an actual physical object that they can touch and see to be able to solve addition problems. Black counters are equal to a +1 and red counters are equal to a -1. For example, we can solve the problem 8 + 3 easily by using these colored counters. We can see that there are 8 black counters, and we can add 3 black counters to those, and we can count that there are 11 black counters after this addition problem. Next, we'll be talking about the addition of integers by using mealtime stories. Mealtime stories are useful because they provide real-life examples and relations to math problems. An example of this is the problem that goes, suppose Susan receives her refund check in the mail from her school. The total of this check is $200. Susan also receives her weekly check from work in the mail, and this totals an $87. And the question is Susan richer or poorer than she was before receiving this mail? We know that she is richer than she was because she receives 2 checks rather than any bills, and she is richer by $287. Addition is something that we all use every single day, and having different methods of solving addition problems can help different people in different ways. Understanding these strategies is a good way of beginning to gain a solid understanding of addition. Colored counters provide an easy way to have a visual to help solve addition problems, and mealtime stories provide a good and easy real-life relation to these addition problems. There are many different methods to solving addition problems, and these are just a couple of these methods. I hope you have enjoyed this section on adding of the addition of integers, and now here's Destiny Clowers with a little more addition and subtraction using integers. Thank you.
All right, thank you, Taylor. You did great. So I'm going to be continuing the addition and subtraction of integers, but before I do so, I want to tell you all a funny little story about myself. It's kind of silly now that I'm older, but when I was in early middle school, I honestly had the fear of the word integer. To me, it sounded like the numbers fraction, derivative, logarithm, and those kind of just sound like big, nasty numbers that you don't want to calculate, and that's what I thought the word integer meant. So once I finally learned that integer was just a whole number, or a number that wasn't a fraction, I was super excited. They're my favorite kind of numbers. So my name is Destiny Clowers, and I want to help you all have a better understanding of integers and how we can use them in many different ways to solve problems. So let's get started. So in order for us to have a better understanding of integers, I will be covering the topics of addition of integers by using a number line and subtraction of integers by using colored counters. So we're going to begin with the addition of integers by using a number line. And this addition can be thought of as starting at point 0 and then jumping from point to point until landing on the correct answer. So how would we illustrate 5 + 4 on a number line? Well, you would start at point 0, and you could either jump from one point to the next until you get to 5, or you could just start from 0 and jump all the way to 5. So to add 4 to that, we would then start once again at point 5, and the tail of point 4 would start at 5, and we could jump all the way to point 9. So right here we can see 5 plus 4 equals 9, and that's why we've landed on the 9. So therefore, we know that 5 plus 4 for sure equals 9. Now, moving along to the subtraction of integers by using colored counters, we can think of this subtraction as using different colored counters to represent the positive and negative integers. And after that, you would just take away the correct number of counters until you've reached the correct answer. And over here, I haven't noted that the black counters represent positive integers while the red counters represent the negative integers. So if we wanted to solve this problem, 7 minus negative 3 using colored counters, the easiest way I think to solve this problem is to represent 7 with a loop of 10 black counters. So we can see our 10 black counters right here, and then 3 red counters in another loop right here. So once you've taken away those 3 red counters, since we're going to subtract negative 3, we're just left with these 10 black counters, and since they are black, it is a positive 10. So therefore, we can know that 7 minus negative 3 equals 10. So as our time together comes to a close, I hope that each of you were able to see how visually beneficial both of these methods can be. For those of you who like to physically see your answers, both of these methods can definitely benefit you in our classroom. Even those of you who are hands-on learners, using different approaches like the colored counters can help you as you get to physically place the counters and physically take the counters away. So these are good for hands-on learners as well. So all in all, my goal was to familiarize each of you with the addition of integers by using a number line and the subtraction of integers by using colored counters. And although I only showed you all 2 of those methods, there are numerous other ways that you can solve problems by using integers. And thanks to Taylor, she showed us a few of those, and I hope that between the 2 of us, you're able to find a method that is beneficial for you. Now, while we're still on the topic of integers, there are also many different ways to test those whole numbers for divisibility. So my pal Jared will be showing you guys some of those different divisibility tests. So, Jared, the floor is yours.
Why, thank you, Destiny. Alrighty, I will start by asking y'all a question. Have you ever attempted to do the splits before? Sounds silly, but roll with it. It was probably a painful experience if you have done it. Excuse me. And if you haven't, well, I would suggest not doing so. With that being said, it may seem like division and divisibility, it sounds as painful to do as that, but I promise it's not. Divisibility is much more easier to do and more enjoyable to do than the splits. Now, I'm going to explain this in 2 parts. First, I will give you the textbook definition of divisibility, and then we will go through a few example problems to help you understand the concept. Now, let's define divisibility to begin with. How is it described? Well, I think we can rephrase it as a question right on here. Can a large number be divided by a smaller number to get a number with no remainder? That is ultimately the goal. The number is divisible into a larger number only if the number has no remainder and is therefore a whole number. Now, what's the point of all this? Well, the main idea, what I want you guys to understand is that this is a good way to help you understand the factors of a number. And this all stems from the concept of division. You have 4 components on it. You start off with a dividend, a larger number, such as 29, 53. And then you have a divisor, which is the number you are dividing by. This can be 2, 5, or 10. It is typically smaller than the dividend. The quotient is the answer that you get when you divide the dividend by the divisor. And then if you have a remainder, that means you have a number and then some left over. In numeric terms, this is typically represented by having a decimal and then having numbers to the right of that decimal. You don't want to see that because that means the number is not divisible. So, I understand that some of you just don't understand how to see this from a textbook sense. So, we'll go through some examples. Let's start with the number 36. Now, I'm going to encourage you guys to stop the video here and try to figure out if it's divisible by any of these numbers here on the left. Now, I'll give y'all a little hint. Look at this factor tree right here. This will tell you some of the divisible numbers. Good. Now that you guys have paused and solved, I will go ahead and tell y'all that 36 is divisible by 2, by 3, by 4, by 6, and by 9. We know this because we can do simple multiplication, or division in this case, such as 36 over 2 is equivalent to 18, which is the same thing as saying as 2 times 18 is 36. And in the case of 4, well, as we see here in our tree diagram, 9 times 4 is equivalent to 36. So if we were to divide 36 by 4, we would get 9, and vice versa for 36 over 9 equals 4. Now, while you can do the division, there are some tricks that you can use to make this process go a little quicker. For example, let's say you're trying to determine if a number is divisible by 5 or 10. Well, all you have to do is look over here in the ones place, and if that number is 0 or 5, it's divisible by 5. And only a number of 0 in the ones place is divisible by 10. So, look at the ones place for 50. It has a ones value of 0. This means that we can divide by 5 and 10 for 50 over 5 equals 10, and 50 over 10 is equivalent to 5. Now, if we were to do it with 95, see here, the ones value has 5. That only means that it's only divisible by 5 because according to our rule, it needs to have a value of 0 in the ones if it's divisible by 10. In this case, the math reveals that 95 divided by 5 is 19, which means 5 is divisible into 95. And then there's 31. The ones value here is 1. It is not 5 or 10. That means 31 is not 5 and 10 are not divisible into 31. Moving on, we now look at 3 or 9. Well, for both of them, you just add up the digits in the number, and then you divide them by 3 or 9, whichever you're looking for, and determine, and if it is divisible by 3 or 9, the sum you come up with when you add the numbers will be divisible by 9 or 3. Let me show you an example. We have the digits 9 and 0. So 9 plus 0 is equivalent to 9. This means that if we were to divide it by 3, then 9 over 3 would give us 3, suggesting that 90 divided by 3 would be divisible by 3. And that is the case, because 90 divided by 3 is 30. 30 times 3 is 90. Similarly, if we were to look at this, 9 over 9 is equivalent to 1. That means that 90 is divisible by 9. And we know that because 9 times 10 is 90. With that being said, I want you guys to look at these other two problems and once again, solve it on your own. Alright, now that you've solved that, let's look at the last section, dividing by 4 or 8. Now, for this one, you just look at the numbers. In this case, let's work with 1,192. You just take the last 2 digits of the number and divide it by 4 to determine if that number is divisible into 4. For example, the last 2 digits in 1,192 is 92. That means 92 over 4 is equivalent to 23, which means that 4 is divisible into 1,192. Now for 8, you follow the same process, but you use the last 3 digits instead of the last 2 digits. So in this case, we would use the digit 192 and divide it by 8, which I will double check. is equivalent to 24. Which means that 8 is divisible into 1,192. It's okay to use your calculator. Even your teacher here is not perfect. He needs help from time to time. All right, with that being said, use this knowledge to determine if 4 or 8 can be divided into 3,364 and 9,931. Now that you've done that, I have one more question. Can divisibility be used in real life? You know, this honestly is one of the easiest things you can use in real life. For example, let's say that you're ordering some pizza and you have 4 people in your group. Each person will eat about 4 slices of pizza each, and it comes in a box with 8 slices. You could use divisibility in your new factor skills to determine that you would need 2 boxes of pizza to make everybody happy. Now, think about practical applications. What would you use divisibility for in real life? Think about it. And if you can find a way to use it, write about it in the comments section of the video. With that being said, we have reached the end of our lesson. First, we introduced the term divisibility and explained exactly what it is. Afterwards, we went through some example problems to determine how it can be found, and even found a few cool tricks to use to make the process easier. Now, while you're thinking about the ways to practically apply divisibility, my great friend Michaela is going to work with you to help find some ways to use it in the real world. Michaela, you have the floor.
Thank you, Jerry.
You're welcome.
I'll be talking about applying and illustrating factors. Most people are unaware of the role that divisibility plays in the modern world. Here are some examples. If you purchase an item at the store, when you scan the item, it is scanned to read the uniform product code. The scan is checking for errors by making sure it passes the divisibility test. If you enter your credit card number to make a purchase or a donation on the internet, the number on your card must pass a divisibility test to be accepted. The barcode at the bottom of the letter is read by a scanner at the post office. The valid of the zip code is checked by seeing if the sum of the digits is multiples of 10. The last digits of the International Standard Book Number that identifies nearly every book published throughout the world is chosen, so a special sum of the 13 digits is multiples of 10. Now I'll be talking about illustrating factors and divisibility manipulatives. If you make 3 piles of 5 beans, what other way can you form piles with none left over? The answer is 1 pile of 15, 5 piles of 3, or 15 piles of 1 in each. How many ways can 11 beans be made into a pile of equal sizes with none left over. There are two ways: one pile of 11 or 11 piles of 1. What number can be piled in just one way? Just one. So in our everyday lives, you can use divisibility. Thanks for watching.